Any bacteria is going to have divided multiple times in 7 days. So believe it or not, it's not a huge problem on Earth for life to exist despite getting these dosages. Actually, below, I forget what the dosage is. There's several times higher than this, but there's a certain dosage. Your cells repair themselves. So there's a certain dosage you can require, and if you don't provide more than that dosage, you're not going to kill anything anyway. And this is basically below that dosage. So it says you're not going to kill anything. On Mars, however, Mars has a much thinner atmosphere. It may be twice as far away, but the flux that you get on Earth, on the Martian equatorial regions of UVC is 6 to 8 watts. That's not 10 to the minus 9 watts, that's watts per square meter. So pretty much as soon as you put something out in the UV, exposed to the Martian atmosphere without any protective covering at all, it's going to get killed by the UV. So all you really need is a tube that's going to run outside of your base and back in. The only thing you've then got to worry about is what you make it out of. A lot of glasses are actually opaque to UVC. So, however, a lot of plastics are really good at transmitting UVC. So you need a plastic tube. I believe borosilicate glass, Pyrex, is actually fairly transparent to UVC as well. So you either need to make it out of Pyrex or you need to make it out of plastic. So killing bacteria that way is really easy. So the other thing that we were actually asked to look at by the engineering team was the water quality throughout the rest of the HAB. And the other reason we were interested in this was, maybe we could use the greenhouse water and reprocess that back into shower water without going through the separate collection steps, because all the water from the HAB is processed through the greenhouse. So basically, we did the water quality tests here. You can see this is Lewis taking a couple of samples, one in the outside gray water tank and one in the greenhouse itself. So for drinking water, the standard is no colonies, no detectable colonies, and the bathing standard is 100 per milliliter total and 20 of the gram negative. And again, we have a couple of pictures of Lewis making plates up to do the testing. So here's the basic setup of the GreenHab. You have the shower, and the shower water goes into the outside gray water tank that's buried outside the greenhouse. That runs through these large filters that supposedly take out some of the harmful bacteria, and then it goes into tanks of water hyacinth and duckweed, and then more hyacinth, and that removes nitrates and phosphates and a lot of the harmful bacteria. So here's the clean water from the shower head, the water after somebody had a shower in it. The gray water tank, you can see, is actually slightly darker than that. Basically, this water's been sitting in a tank outside and getting slowly worse. And then you can see these actually getting slightly cleaner as they move down the line, as they've been run through these tanks with these different plants. So here are some of the samples that we took. Again, you can see like no samples on here, and you can see a good collection of bacteria on the cells after the shower, and a better collection on the ones from the grey water tank. And then you see here they just explode, and we'll get into that in a second. Basically, we made the plates up of regular agar and also the gram-negative selective agar, and incubated them overnight for 12 to 16 hours at body temperature, and then you basically count the plates. This was basically what we found for the different tanks. The grey water tank had an awful lot of bacteria in it, but didn't have much of the E. coli and stuff like that. However, once we brought the water into the greenhouse, it goes from being relatively cold. It was about 30 Fahrenheit, like most of the time. So it was right around freezing. So that the tank outside was just a little bit above freezing. And then you brought it into this greenhouse that was running about 90 to 100 Fahrenheit, and all of a sudden the bacteria are like, whoa, it's party time. So the bacterial levels just like kind of shot through the roof there. And then you can see them being cleaned up in the tanks with the plants. Yeah. So I mean, basically, by the time you get to the last tank, you have less bacterial levels than you did in your starting tank outside, and that's all just through the action of the plants. So we found that when we were there, the GreenHab was functional and fairly efficient at decreasing the bacteria. This last tank here is just a collection tank, and there's no plants in that. And a quarter cup of bleach was added daily to that. And basically, we concluded that really you want to skip that tank, because the bacteria was growing in that tank, but it wasn't growing, it was being killed off in the tank with the plants. So that was one of our major conclusions. Later on, about a couple of months later, I think it was actually a month and a half, a later team did another survey on the water quality in the tank. And they were specifically looking at drinking water standards in the HAB. But they also did a study in the water quality in the GreenHab. The interesting thing with them, so the yellow down here is the total count in our test. And the green was one of the tests they did at the beginning of their rotation. And the purple was one they did at the end. I'm not entirely sure why, but they had a huge spike in the bacterial levels that they discovered at the end. I'm guessing, but I don't know, that the weather warmed up a lot, and the bacteria in this tank, instead of being in hibernation because it was close to freezing, was now at a nice warm temperature and basically just multiplied like crazy. Anything around 1 million here is equivalent to water you find in a sewer. So all the water that goes down your sinks and your toilet and basically runs down the main street. This is kind of equivalent to sewer water. Now, we weren't putting any, there was no black water. This was only gray water. This was water from showers and the kitchen sink and the lab sink that's going down here. Yet the bacterial levels in here are basically equivalent to a sewer running that time. And the interesting thing was that despite that, they recorded much lower coliform quantities, gram-negative quantities, than we did. I don't know the reason for that. We think they used a different agar. We think they used blue agar rather than red agar, which is more selective for E. coli, and that's only typically about 10% of the gram-negative, and that would explain the differences here. But I don't honestly know the reason for that. But they had less than we did. Okay, so basically just the conclusions. We found it was really simple, straightforward to implement a recycling shower that met safe bathing standards. It would be relatively easy with just a few components to do this on a permanent basis, basically a dedicated water pump and a heater.
Yeah, do you find a UV sterilization comparable to the chlorination?
We didn't use chlorine for the simple reason that I owned a UV lamp. I didn't have any chlorine on me because from my personal experience hiking, I prefer using UV because it doesn't change the taste of the water. If any of you guys have done a lot of camping and hiking and climbing, you know that these tablets that you get to iodine and that yeah, they end up putting a really kind of funky flavor, and some people don't mind it. Some people even they like the taste of it because they know the water is clean. I don't like the taste of it. I much prefer using UV. So the only reason I didn't use chlorine was I had a UV lamp.
You know what the Egyptians used was pine oil.
I was actually talking to the Pure guys out here about their, they have a little chlorine, and they have some other chemicals in there for flocculation. So basically, if you've got suspended solids, they pull it out of that. And basically, they use this for disaster relief. They were saying most recently in Haiti. And basically, you take a bucket of water from the river, you drop one of these tablets in, and all the suspended solids drop out, and the chlorine kills the bacteria, and then all of a sudden you've got safe drinking water. So it's certainly using a chlorine filter would be another way to go. The other reason for using UV was that if you're on Mars and you need a source of chlorine, well, you've either got to bring it with you or you've got to find some way to extract it in situ. You want UV, all you do is go outside or run a line that goes outside.
The reverse osmosis wouldn't be practical because when your filters run out, you have to go back there to get some more.
Right, yeah, that was one thing you mentioned in your talk earlier, so I thought it was interesting. So I liked UV as the solution, basically because it would be easy to do on Mars, and also it's relatively easy to do on Earth too. Where were we? Okay. So because we fixed the actual shower, we only used it a few times as basically like a proof of concept. We didn't end up everybody using it every day, which I think would have made a really interesting study. Because the one thing we didn't get to do, since only a few showers occurred with this, was we didn't get to monitor the filter, that sand filter, and to figure out how often we'd need to replace that sand filter. Again, at some point this is going to build up with bacteria. Maybe you could use some UV before you put it through the filter. On the other hand, there's plenty of sand out there. You just go and dig up another shovel full of sand and dump it in your bucket. So that there were options there that we didn't quite get to. And at some point, maybe somebody could even implement some sort of like fully closed system, which you wouldn't necessarily need on Mars, since hopefully you've got a plentiful supply of water where you've built your base. But some sort of fully closed system, this could certainly be a part of. The GreenHab, the last tank, we said skip the last tank. The bleach isn't doing anything for it. It's just not high enough concentrate, and the plants are doing a much better job. Another thing you could do is that tank 3 water, it looked like reasonably decent pond water. If I'd seen that out at a pond, just walking around here, I'm not sure I necessarily would have wanted to go swimming in it, but I wouldn't have worried about it too much if I did. Having looked at the bacterial levels, maybe I should think twice about that. But nevertheless, with a bit more filtration and UV, it should be relatively easy to bring even the GreenHab water up to bathing standards, at least. So the only other conclusion was that given some of the water levels, bacterial levels that were going through there, I think that maybe with an extra tank or two plants that you could maybe even process black water through this system, assuming you can get rid of the extra. Right. Right, yeah, there's a lot more issues involved with that, but nevertheless, it would be a possibility for somebody to consider doing at least a small-scale experiment at MDRS. And this is a last little quote. If any of you guys know MDRS, you'll know that the shower is right next to the engineering center. So this was my favorite quote from one of the people when I was working outside with a circular saw, and the poor girl who was having a shower at the time was having visions of B movies with the serial killer, Jason was, or someone was after her. All right, so that's the end of the talk. All right, thank you. Any more questions?
Well, maybe not so much a question as a comment. When NASA was running their ALS program, they qualified a UV light filtration system, sterilization system that was a meter of pipe surrounded by polycarbonate pipe surrounded by UV LEDs that was sterile, getting perfect sterilization in the steady state. I know they're processing black water with a series of biofilms and
right.
drinking quality.
Yeah.
There's several published papers on that that might be
right. Yeah, there's lots of ways of doing it. Like commercial stuff. Normally, what you do is you have UV lamp. Oh, they don't have it. It's like your fluorescent lamps, and you pass those through a chamber, and you run the water through that, as opposed to putting LEDs around the outside. But I mean, any kind of way you can get the UV dosage in there. The only issue with UV that I'm particularly aware of is that if you have suspended solids, then bacteria can hide in pores and in crevices.